Namaskar, this is Mrs. Neela Kalyan Jabdari and today we will be discussing the concept of closure or how to determine the closure when the two faults are intersecting. Yes, and I have just made a small model, just for you guys to understand as to how is that what happens or what happens to the closure when we have two faults intersecting. In this case, again guys, please understand we have two cases again. When we are talking about closure produced by intersecting faults, we have two cases again. Case A or Roman 1 is when we have the upthrown block in the center. I will explain to you what exactly it is. And the other case is when we have the downthrown block in the center. Now what is it? See, understand one thing. See, supposing this is one fault, yes, and the other fault, yeah, and the two faults are intersecting. The two faults are intersecting. You getting me? They're intersecting. So what we are going to talk about is this area. Yeah. Supposing because of this faulting effect, yes, it has so happened that this central block, because of this fault and this fault, it has so happened that this central block has moved up. This part, only this part I am talking about. Okay, only this triangular part I am talking about. So what happens is if this part has moved up, yeah. So we have the upthrown block in the Downdip region. The other scenario, the upthrown block in the Downdip region, yes, we are talking about, and the dip is towards you, yeah. So it is the upthrown block in the Downdip region, and the other cases we have the downthrown block. The block is this central block has gone down with respect to the blocks at the side, yeah. So the downthrown block in the Downdip region, that is case 2, yeah. So first we will understand case 1 as to how to determine the closure when we have the upthrown block. This block has been thrown up as compared to the surrounding area or surrounding blocks, yeah. So when we have the upthrown block in the Downdip region, what exactly happens? Yes, we'll just understand that. Yeah. So before we even we move ahead, what we do very first thing, as everyone knows, what we do is we are going to first mark regional strike in it. Yeah. So here this is the regional strike, this is the regional dip. So we write here this is regional strike and dip, and we want to mark north. Yeah. If this is so, your regional dip is towards south. This is clear to us. Now we understand, or we quickly draw a contour map for this thing, contour map figure. This is 1200 meters. Yeah. So we will write here 1100 meters. This is 1000 meters. This is 900 meters. This is 800 meters. $700 meters. 600 meters, 500 meters, 400 meters, and you have one more, that is 300 meters. Alright. These are contours of the area wherein you have two faults. Say this is one fault. Yeah, this is the triangular area that I was just showing, this part, this is one fault, AG, for example, this is A, G, fault AG, yeah, and the other fault. So say this is fault AN, fault AG, fault AN. Yeah, the two are intersecting and we are just drawing the figure or the part that we want or we need to understand. That part what we need to understand the concept. Yeah. So by the way, very first thing, what are we discussing? We are discussing closure, determining closure or of intersecting faults. Closure of intersecting faults, and we have the upthrown block in the Downdip region. This is the Downdip region. So I will just write with the other color, that is upthrown block in Downdip region. Yeah, upthrown block in center in Downdip region. Yeah. Now this being said, what we understand is this is 1200 meters, and because this is upthrown, now how do we know it is upthrown? Yeah. So very first thing that I should be doing now is I will first provide you with certain values. Yeah, I'm just choosing a color. I think this will be more prominent, the yellow one. Yeah, so here it is, 21,000 meters. That is, A is at 21,000 meters. This is 2,000 meters. This next contour which is in between is 2,000. I'm just writing a little small. This next contour is 1900, 1900. But I'm speaking aloud so that you guys know what exactly I'm doing. Yeah. This is 1800 meters contour, and this is all in meters. It's just that I'm not mentioning everywhere it is meters, but it is in meters. Reason being space. Yeah. So you have 1700 meters. Then you have 1600 meters. Then you have 1500 meters. Then in between you have 1400 meters. Then you have 1300 meters. Then again in between you have 1200 meters, 1100 meters. Then again in between the two you have 1000 meters contour, 1000 meters. Then you have 900 meters contour. Below that you will have 800 meters contour. You will have 700 meters contour below that. Then you will have 600 meters contour. This is your 500 meters contour. Then next you will have 400 meters contour, and you will have 300 meters contour. Now, because I told you earlier that you are going to have upthrown block in the center, that's why you knew it. But now after looking at the contour map, it is very clear that the central block has gone up, reason being you have higher values, okay, of contours in the central block as compared to the surrounding area. For example, 2100 meters is coming in contact with 1200 meters. Yeah, 1900 meters is coming in contact with 1100 meters. 1700 meters is coming in contact with 1000 meters. Yeah. So what is happening? This block has been thrown up, meaning this area that we were talking about has been thrown up with respect to the surrounding area. Yeah. So what we are going to write here is, this is upthrown block. I just write here upthrown. Upthrown, yeah, and therefore these two are downthrown. This is downthrown and this is also downthrown. Yeah. So now what we are understanding from this, we know how to calculate the throw of the fault. In case of with the help of contour maps. So here we go. The throw of the fault is going to be how much? 2100 minus 1200. How much is it? 900 meters. Yes. So 900 meters is the throw of the fault. Yeah. So now what is going to happen is, see, understand one thing. This is one case which is very much similar to when we had singly plunging anticline with the upthrown block in the Downdip region. This is very much similar. This is it's just that you have two intersecting faults. That's it. Otherwise, just imagine. See, we have this block, upthrown block in the Downdip region. Now, this block has been thrown up. Just understand one concept here. See, it is this part resembling. This is very much same, coinciding now. Yeah, this is coinciding now. Is this clear now? This is coinciding. Yeah, this is just for you to understand what is exactly happening now. Okay, and after faulting, this block has gone up like this. This block has gone up. So you have the upthrown block. Here it was like this earlier. The two points being one and the same. These 2 points being one and the same. These 2 points I'm talking about being one and the same. Yeah, and after faulting, this block has gone up. Yeah, so we have the upthrown block in the Downdip region, and here again the closure will have two cases. Case A, partial sealing. Case 2, complete sealing. In case of partial sealing, what will the closure be dependent upon? The closure will be dependent completely upon the throw of the fault. How much is the throw of the fault? You getting me? So here we go. Here this is one. This is one and the same point first. After faulting, here it is like this. Yeah, after faulting it goes up like this. Yeah, respectively. So how much ever is the throw, only that part is sealed, and therefore what happens is the closure will be equals to the throw. Why? Because only that part which has been thrown up has been sealed, and the other part, the lower part, is not sealed. Yeah, it is impermeable, and the above one is impermeable, and the below one is permeable. Yeah. Therefore, what happens is, we are going to have two cases: partial sealing, complete sealing. Partial sealing is when it is only the throw of the fault. How much ever the block has gone up, only that part is sealed on either side. Meaning only this area. This much area is sealed. Below this area. That means, see, only this much area is sealed. Below this, whatever area is there, it is not sealed. Therefore, this is partial sealing, and therefore, whatever oil and gas is coming from here, okay, it will get stocked up only up till this area, partial sealing. Yeah, and in case of complete sealing, what will happen? It depends upon the structure in the Downdip region. Therefore, it will depend upon how many contours are present. Till the bottom, or till the bottom where the fault meets the till the bottom of the fault, rather I will say. Yeah. So here, what is happening is, case of partial sealing, what is happening is, this closure will be equal to the throw of the fault. In case of complete sealing, it will be right till the bottom. Yes, it will be right till the bottom. It will be right till here. That way. Yeah. And otherwise, in case of partial sealing, because this block has gone up, only this part will be sealed, and only this part will give rise to closure. In case of complete sealing, entire structure will be the closure. Yeah. So what we understand here is, we want to have lower boundary of the closed area, which is equal to the partial sealing. Yeah. And in case of partial sealing, rather, the lower boundary of the closed area will be 900 meters down, which is equal to the throw of the fault. Yes. So in case of partial sealing, what do we have? The closure will be equal to the throw of the fault. Yeah. So what is it? Throw of the fault is how much? It is 900 meters. Why did we say that? Because 2100 meters. Okay, the higher value on the upthrown block is coming in contact to 1200 meters contour. You just subtract the two. You subtract 1200 from 2100 meters. The value that you get is 900 meters. Therefore, you conclude that 900 meters is the throw of the fault. And therefore, for partial sealing, what do? You go down by 900 meters. Yeah. Why? Because it is a throw of the fault. Yeah. And closure in case of partial sealing completely depends upon the throw of the fault. We've studied that earlier as well. So here we go. 2000 meters. So this is 1, 2, 3, 4, 5, 6, 7, 8 and 9. So at 1200 meters, 900 meters minus subtracting 1200 meters. At 1200 meters, you just draw a line with green. I always say lower boundary of the closed area, preferably mark it with green mostly. Yeah. So this line which is the lower boundary of the closed area in case of partial sealing is PR. Yes, and I'm going to label this as lower boundary of closed area in case of partial sealing. Yeah, and then in case of complete sealing, what did we say? It depends, the closure will completely depend on whatever is the structure, the Downdip region, meaning till the last contour, wherever the fault intersects or meets, till that contour you are going to have the closure. Yeah. So in this case, the last contour that we get to see is 300 meters. Yeah. So what we are going to do is till the bottom, this is going to be your closure. Yeah. So this is the closure in case of complete sealing. So we just want to write here lower boundary of closed area for complete sealing. Yeah. And we want to write closure for partial sealing is how much? It is 21,000 meters minus 1200 meters, which is equals to 900 meters. Yeah. And what is the closure for complete sealing? Closure for complete sealing is equals to 21,000 meters minus this 300 meters. You are getting to see this? This is 300 meters minus 300 meters, which is equals to 1800 meters. So we have understood the concept of what happens for in case of intersecting faults. What happens when we have the the upthrown block in the center. Yes, we have two cases, that is partial sealing and complete sealing. In case of partial sealing, yes, the closure will completely depend upon the throw of the fault. The throw of the fault in here was 900 meters. We got to know that because the values of the contours are given. 2100 is intersecting with 1200 meters, at the side. Therefore, the throw of the fault is 900 meters. Therefore, we come to a conclusion. Closure of the fault in case of partial sealing is 900 meters. And then closure of the fault in case of complete sealing completely depends upon the structure in the Downdip region. Therefore, the last contour that comes in contact with the fault here is this 300 meters. Yes, and therefore what we do is we subtract 2100 from 300, which is 1800 meters, and therefore the entire area will be covered by oil and gas. That is a complete closure. And this is the lower boundary of the closed area for complete sealing. This, yeah. So in case of closure for partial sealing, we are going to have triangle APR. Yes, and in case of complete sealing, you are going to have triangle AGN. Yes, this is triangle AGN in case of complete sealing. In case of partial sealing, triangle APR will be the area which will be completely covered with oil and gas. Yes, so having understood, we'll stop here. We'll move further in my next video. Thank you. Have a wonderful evening.